Problem says a spacecraft travels at a speed of 53% of the speed of light relative to Earth. The spacecraft launches a probe at a speed v, and that speed is 73% of the speed of light, but that's relative to the spaceship. So what would be the speed of the probe relative to Earth? All right, so in some of my videos on relativity, I mentioned that according to Einstein's mathematics, there is a speed limit to the universe, where nothing can go faster than the speed of light. So if we were to use classical physics on this problem, the speed would exceed the speed of light, and that's a problem according to Einstein. See, if we used classical physics, we would use what's called Galilean relativity, where if you have one object which is stationary, and then you have this ship moving with a speed of 0.53 c, and then you've got a little probe going at supposedly 0.53 c plus 0.734 c, then the result of that would exceed the speed of light. 0.53 plus 0.734 makes 1.26 c relative to Earth. But according to Einstein, this cannot happen. So instead, we use velocity transformations for relativistic situations like this. Formula for this situation would be u equals u prime plus v over 1 plus u prime v over c squared. Now, what do all these things mean? So v is the speed of the moving reference frame. You could call it S prime. That would be the ship relative to Earth. Which is frame S. So see, Earth is a stationary frame, not moving. But we have the frame of the ship, which is moving. So I'll call that S prime. All right, so that's V. Now what is going to be U? And what is U prime? U prime is the speed of an object relative to S prime relative to the ship in this case. So it's the speed of the probe relative to the ship. Then U is the speed of the object relative to S, which is relative to Earth. Alright, so all we gotta do is just plug in the right things into the right places. So this is gonna be 0.53 C. That's this. Okay. U prime will be 0.734 C. Okay, that's the velocity of the probe here relative to the ship. And then we'll find U. Alright, so we'll just get U equals 0.734 C plus 0.53 C, but we don't just stop there. Because this is a relativistic type of problem where speeds are significant in terms of the speed of light. So we'll do 0.734 C times 0.53 C divided by C squared. Once you simplify all that, you'll get that U is 0.91 C. Keep in mind that the C's here can cancel, so that makes the calculation not too bad. Alright, so instead of being 1.26 C, we get 0.91 C. 91% of the speed of light.